Hi guys, good morning. In this video, we're going to see the problem distribute money to maximum children. It was the first problem ever, which was harder than the fourth problem of this contest. But yeah, let's see this problem quickly. It says that we are given an integer called money. It denotes that the amount of money which we need to distribute to the children. Let's say the children is the number of children we have, and we need to follow these rules that all the money which we have, it needs to get distributed to these children. Each child should have at least $1 and nobody should have $4. And we need to return the maximum number of children who may receive exactly $8. Let's see what we need to do. If we have this $20 and have these three children, we need to distribute those $20 to these three children in such a way that maximum number of children have $8, and it also need to satisfy the condition which you mentioned 3 above. First condition which we see that everyone must receive at least $1, which means that out of those $20 I need to put $1 initially because everyone should have. I put $1, so remaining will be $17. Now let's think. 17 are remaining. I want to make exactly 8 to get my actual good answer. So what I will do is I will try to put $7 now in every box. Cool. I just try to add 7. Cool. When I try to add 7, remaining will be $10. Again I try to add 7, remaining will be $3. Then it's remaining, right? Now I can't add 7 because it's less than it's 3 is less than 7, right? So I need to add $3. So ultimately something will become like this: $8, and $4. Good. Oh, this condition we saw, it can't be true because we specifically marked that nobody should receive exactly $4. Now I just need to remove this $4. I need to give him less or more money, but I need not to have $4. I just try to make it 3 or maybe 5, anything, but I need to get rid of this 4. I can do is I can just borrow one money from the next child, so it will reduce to 7, and I'll just add it, which it will become 5. So now the conditions are satisfied, but you can easily see that one child got bad in this, but yeah, maximum will be 8. In this only one, which is answer is just 1 because one child has only $8 and no other child, and it's the maximum number we have. So it's pretty simple that we need to think of cases. As we saw that what if it becomes 4? What if it does not becomes 4? What if it can dissolve into multiple childs? Every what if is just a case. Let's see how. So firstly, before thinking of any case, let's have some naming. M, money. C, children. Although I will just write money and children, but yeah. So firstly, at the first condition to satisfy, we need to give every child $1. So the remaining money will be nothing but money minus children. In the code, you will see something like this. Cool. Now, it's a case 0. Why it is 0, not the case 1? Because it's pretty trivial that in this it was said, if there is no way, then you need to return -1. Let's see what is that no way. And that is the no way that if the money, let's say money was 3, but the children were 4, so you would have put 1, 1, 1, but you don't have money to put in the 4th child. What will happen? You won't be able to put money, which means that the condition itself got denied. So if money remaining is less than 0, which means that you subtracted here, right? Money minus children. If that becomes less than 0, so I need to return -1 because that is the case which is not possible at all. That's the reason. So after we assign $1, what we thought was that now my aim is to assign $7 to every child, right? So now my aim was to check how many number of $7 I can assign to child, which will be like nothing but money remaining by 7. But after that bunch of 7 is made, still some money can remain. So that is value other. Okay, some other value is remaining. We have a bunch of multiple 7s and some value which is remaining. Cool. Now we need to think, okay, that remaining, which means that value other, what if that value is 3? What if? That comes our case 1. When the count, which means the bunch of that 7 is less than the children, which means that, okay, I can assign one 7 here, here, but the number of children are more, so I can only assign in some small range. Remaining will be some space. When a space comes, I need to think the value other which was remaining, is it 3? Value which was remaining, is it 3? If it is 3, and also only one block is there, which means I have to place that 3 in that one block only, which means that the remaining space is just, okay, suppose that these are the number of children's. If this is the whole count 7, remaining space will be number of children's remaining. If remaining space is 1, I have to put that value other in that space, which is 3, which will actually in turn will make it a 4. Thus, what will happen is I need to return count of 7 minus 1. You understood why? Because count of 7 is this particular range, but as the last one would become 4, so I need to remove 1 from the count of 7 to actually make the other one as 5 or 3. So thus the count of 7 minus 1 would actually be the maximum number of good childs, or by this problem, children who may receive exactly 8. Thus we have to do this. But you can also see that, okay, count of 7 can also be 0, right? What if my money is 4 or 5? Then count of 7 can be 0, because I have no count of 7. It can go to minus 1, but ultimately the answer should be 0, right? So I just do a return of maximum of 0 comma count of 7 minus 1. While on the other case, what if the number of remaining spaces are, let's say, 2? So I can just distribute that 3 which I had. Let's say here the spaces remain are 2, not 1. So I can distribute that 3 to 2 and 1, which will ultimately make it a 2 and a 3, which is not a 4. So I'm good. So I can just return what is the count of 7 here, and that will be my answer. That will be my children's having exactly $8. And that is in the code, you will see something like this. Is exactly the same condition I showed you here and here. Now comes the case 2. See, in the above case we saw, what if the count of 7 is less than the children? What if the count of 7 is more than the children? Which means that the count of 7 I got bunch of 7 is more, which means that count of 7 is more. So I have to place some of the last 7 bunches together, so it will for sure not be 7. So the good ones will only be this range, which is count of 7 minus 1. Thus, sorry, which will be children's minus 1, because I just put remaining count of 7 in the last child, which is this one, and thus it is the remaining children's, which is which is children minus 1. So I just return a children minus 1. In the code you will see something like this. And the last case, as we saw, if count of 7 is more than or is like less than a children, more than a children, we will see if it is equal to children. If it is equal to children, then again, what if the value other, if it is 0, then I can simply add a 0 and then I can just get a 8. I'm a good. So I can just return, okay, what is the count of 7? But what if this value other is something 2, 3, 4, anything? It will not make it as an 8. And for sure it will be more than 8, because count of 7 was exactly equal to my children. So the last thing will be more than 8, but it won't be 8, because count of, because value of other has some other value, so it will automatically discard. Remaining will be what? This thing, which is count of 7 minus 1, or we can also say children minus 1, because both are same, children and count of 7. And thus you can see the same thing exactly in the code. Exactly same thing. I just showed every part of code by explaining only. It is the code, okay, if remaining minus 1, then I had count of 7 and value other. Then it was case 1, it was case 2, and it was case 3. So I hope that you guys understood. It was just implementation and finding out the cases, okay, what all cases can be possible. Although it was pretty like hard kind of incomplete, as you can easily see, number of votes minus 112. So yeah, you can easily see. Goodbye, take care.